Hi, it's Mr. Mac, and we're going to be looking at a calculation question about transformers. But before we do, have a look at this picture. It's a typical power pole in Australia with 3 wires at the top, which is high voltage, and 4 wires below that. Underneath that you can see a box, which is the transformer, and there's also a cable there for optical cable. The high voltage is at the top, it's 315 kilovolts. The transformer then steps that down to 22 kilovolts. And here's the calculation question. The ratio of the number of turns in the primary coil to the number of turns in the secondary coil in a transformer is 1 to 500. The primary coil is connected to 230 volts AC, drawing a current of 3 amps. Find the voltage and current in the secondary coil if it is connected to a circuit with a load.
Welcome to Mr. Mac's Physics channel. He can explain things really well and is a lot of fun to watch.
It's the ratio of the number of turns in the primary coil to the number of turns in the secondary coil in a transformer is 1 to 500. At this point, I'm going to ask the question, which module and what are we looking at? Don't have to remember the numbers, that's fine. Electromagnetism is module, exactly right. And we're narrowing it down on transformers. We're told that the number of turns in the primary, in a ratio, it's the same as a fraction. Okay, so that's the interchange between the two. I think that might have been year 8 maths, but anyway. So NP over NS is 1 over 500. So once we put it into fraction form, it becomes a little more obvious what to do. We're given in the question VP is 230 volts, drawing a current of 3 amps. So we've now got IP is 3 amps. Just remember what P is, primary, and NS is for the secondary. And we're asked to find the voltage and the current in the secondary coil. I'll do it down. Vs equals something and Is equals something. That's the data. That's what we want to find. And next step is, of course, to get something from the formula sheet. We'll actually need, for this question, we'll need 2 different formulas. But let's do it bit by bit. Let's get the transformer one, which is Vp over Vs is Np over Ns. So this is the fun bit. Okay, this is the fun bit because we already know Np over Ns. It's up there. We know the primary voltage, it's there. We want to find this one. So next step is substitute. Do the substitution mechanically so we don't flip the wrong thing at the wrong time. So 1 over 500 from the question, and this one, what do we know? We know Vp, so we need to be very careful that we put it in the right place. We want to find Vs. That's nice now. We can see what to do really easily because one unknown in the equation, and you see down there, yeah, I'll just take it down a little bit further. Okay, so Vs, if I work this out, those two will actually get together. So Vs by itself will be 500 times 230, 115,000 volts, 115 kilovolts. Actually, that rings a bell. That makes sense. That's what there's a step-down transformer near your house. It steps down from 115 kilovolts down to 230 volts. So that actually makes sense. So somewhere near your house, probably up on a power pole somewhere, or perhaps in a green box beside the road, there is a step-down transformer that does this. So it's quite common. The question now is, we want to find the current in the secondary coil, assuming there's a load. Okay, and that's fine. We now turn to a different formula in the formula sheet. So I'm just going to go next to that. And this one is a bit trickier so don't memorize these. Okay, this is the sort of thing that we need to look at the formula sheet and get it down exactly. So VP IP equals VS IS. Now, what does that mean? VI is power. So the power in the primary equals the power in the secondary, assuming we've got 100% efficiency, and that's called an ideal transformer, which of course we're noting along the way that there's no question about efficiency or inefficiency. So we just assume it's an ideal transformer unless we're told otherwise. So VP IP equals VS IS. We want to rearrange that to put IS as the subject. That's easy. IS is VP IP over VS. Okay, so we're just dividing both sides by VS and swapping sides. And substitute. So we've got 230 volts times 3 amps divided by the voltage that we just found is 115,000. And that should give us 0.006 amps. And so we've answered the question. This one, after we get to the data, we started there. We've got a formula here and a formula here to answer the question. So this may be, as it's written there, 2 things in one question. So always read the question carefully. If you found the voltage and then you reread the question, it says, oh, find the voltage and current. 2 words, and missing that out will cost possibly 2 marks. So always read the question very, very carefully. And that's how you do a calculation question for transformers. You can subscribe to Mr. Mac's Physics channel. I'm Mr. Mac. Thanks for watching.